Hey guys, welcome back to AT Audio. Today on the channel we're going to be taking a look at this Pioneer SX-980. And so this unit was sent to me by one of my subscribers, Troy. If you're out there watching, Troy, hello. And he asked me to go ahead and get this thing up to snuff. And so I'm probably going to do my basic restore on this. And so what I mean by that is I'm going to take a look at the power supply board, probably change out the capacitors there and also the transistors. I'll also take a look at the amp board and change out the capacitors and transistors there. From there, I'll branch out to the protection circuit board, and from there, I'll probably just clean the controls, update the lighting, and just fix any issues that I identify, which I believe this receiver is in pretty good working condition with just some minor issues. And so we'll go ahead and test all that. But before we get started, I need to remove this case and this faceplate. And so I'm going to do that off camera. But if you haven't seen me do that before, all I'm going to do is remove the two screws on the side. Once we pull all these knobs out, it'll reveal a couple of nuts on these dials. And then also there'll be two screws up here. And from there, that whole faceplate will be able to slide off. And so I'll go ahead and do that. On the next camera shot, you guys will be in looking at the receiver, and we'll go ahead and do a visual inspection and see what we see inside. All right, guys, so looking in this receiver, this just goes to show you never know what you're going to find in these receivers. And so when I open this up, the lighting was just kind of laying here, which this isn't good because this is exposed. This has voltage on it here, so this could have caused a short or caused a problem. Now, I tested everything, and everything seems to be working. But this will have to be addressed. And so if you paid attention to one of my previous videos, and I'll throw a link in the description and a picture on here as well, you'll see that I've made new replacement parts for these. So I'm going to replace all of these light sockets, and then that way we won't have this problem anymore. The other thing too is that on some of these, when you put the new LEDs in there, they're longer, and so they actually won't fit. And so really what you have to do is trim the bottom of these LEDs to get them to go in there and work. So we'll take a look at that as well, so we can make sure that these will fit in there okay. The other big thing I noticed on this receiver is that this receiver's had some problems before in the past. I'm going to just put that out of the way. And you can tell because we've got some new fuses in here. And so at some point, this thing blew some fuses, and it looks like it had to do with something on this power supply board because all the capacitors have been changed out on this board. And they didn't use good capacitors. They used the cheap Chinese capacitors, and so every capacitor on here, except for these two, these are Nishikon, so these are actually good capacitors, but all these other ones are the cheap Chinese ones, including this big fella right here. And it already feels like it's bulging. So probably a good idea. We're going to remove all of these capacitors. I'll probably, since these are Nishikon, I'll probably take these out and test them, just make sure they're good and no issues, and then I may reuse them or I may replace them, I'm not sure. But at a bare minimum, we're going to change out all the capacitors on here and also the transistors as well. And I'm just taking a peek at the transistors to see if any of the transistors were changed. And I can't tell if any of the transistors were changed or not. So really maybe when I get a better look when I start pulling them out. But it looks like it's the original transistor. So I kind of wonder what happened to why this shorted out. I'm assuming it had to be a capacitor issue, and that's why they recapped this board and not necessarily a transistor, because it looks like these are all the original transistors on here. It's from what I can tell, but it's kind of hard to tell in this lighting. So the other thing is, you probably can't see it, there's some questionable wiring down here as far as what they did to change out some of these indicator lights. So we'll go ahead and replace all that as well and get that looking pretty. Some exposed wires down here as well. So not ideal, obviously, because that can cause an issue later down the road. So I think what we'll do is, since we've already identified some issues with the power supply board, we'll go ahead and start on the power supply board first, which is typically where I start anyways. And we'll go ahead and pull out these capacitors and swap out these transistors. And so on previous videos, I go into this, and so I'm not going to have you guys watch me do this process. But two things I want to point out when it comes to capacitors and transistors. One, a capacitor has polarity. And so if you see on some of these capacitors, you'll see a stripe down the side of them. And that means that's the negative side of the capacitor. And the other side is the positive side. And on the board, you usually see that they indicate that with the plus sign on the positive side. So just make sure that you put these capacitors back in with the correct polarity. The other thing to pay attention to is the pinout on your transistors. And if you're unsure of the pinout of your transistors, whatever your transistor substitutions are, you can look on their data sheet and you can see what the pinout is. I'll put a symbol for the transistor up on the screen now. And basically you have three legs. You have the base, the emitter, and the collector. And those go into the circuit board in a specific order. And usually on the circuit board, it'll either have that picture of the actual symbol for the transistor, or it'll have ECB to indicate which leg goes where. Super, super important that when you do this, you ensure that you're getting that correct pinout into the circuit board, because if you don't, one, it won't work, and two, you could risk damaging something else and causing a bigger problem for yourself down the road. So pay close attention to how you put the transistors into the circuit board. I can tell you from experience, even if you do this a lot, occasionally you'll make a mistake and you'll get the wrong pinout, and just because you're in a hurry or because you're tired or for whatever reason you got distracted. So very, very vital to double check your work and make sure that after we complete this, we always power back up on our dim bulb tester to ensure that we don't have any shorts or any issues, and that we get our relay click before moving on to the next board or next part of our restore process. The other thing I'm going to point out is these transistors here on these heat sinks. And so obviously make sure that when we replace these transistors, we're going back and we're putting new thermal compound on the transistors before we mount them back on here. I recently came across a person who replaced a transistor, and when I opened it up, there was no thermal paste. They had just basically put the transistor onto the heat sink. And so that obviously is not ideal and will not dissipate heat as well. And so that thermal compound does a few things. One, it facilitates the dissipation of heat. And the other thing it does is that, this heat sink and the back of the transistor is not completely flat. And so it'll fill any voids or any imperfections and create that bridge so you have better, more surface area to get away some of that heat. On a previous video, I had someone point out to me like, hey Mike, on your seal pads you're using thermal compound and you're not supposed to. And so while you don't have to use thermal compound on seal pads, I recommend still doing it because the seal pads don't necessarily fill in those voids. And so I've actually read in some of the forums, and some of the old timers will say they still use it. And so because of that, I still use thermal compound on my seal pads as well. And obviously it's not going to hurt anything. It can only help things. I think people like the seal pads because they feel like they can skip that step, and it's kind of a messy step and sometimes can be frustrating, but I go through the process of going ahead and still using thermal compound on my seal pads for that very reason, because I'm going to do everything I can to better the heat dissipation in these units, because ultimately that's one of the major killers of these units. So I'm going to go ahead and start on this, guys, and when you come back you'll see that hopefully I've got all these capacitors and transistors swapped out. This board looks like it comes out pretty easily, and so we've got a screw here, here, and here, and then we've got a plastic grommet here that we'll have to here and here that we'll have to basically depress, and this board should come out. Hopefully we'll have enough wiggle room till we can get to the back of this board and swap out those components. I'm pretty sure we do. It looks like we should be able to. So I'm going to go ahead and do that off camera, and we'll come back once this is complete and after I've powered it up and make sure that we don't have any problems. So give me a few minutes, or rather probably 30 minutes to an hour to do that, and then we'll be right back. Right, so we've got the power supply board complete. We changed all the electrolytic capacitors and the transistors. And so this one had a few new transistors that I haven't had substitutions for before, so I had to do a little research. Not much, didn't take me long to find suitable transistors for it. As with pretty much all my rebuilds, when I swap out the electrolytic capacitors, I always like to upsize them in the power supply board. And what that means is that I keep the capacitance the same, but I increase the voltage probably 1 to 2 levels up. So I was able to do that in this board. A couple things to mention on this. We talked about someone had already been in here and done some work. And so I didn't mention it before, but I want to make sure I mention now. When you notice someone's been in and done work before you, don't assume they've done it correctly. Don't assume that they've swapped out the correct components. Always assume it's wrong. So when I was looking at these capacitors and pulling them out, I was verifying their capacitance in the service manual. And while I was doing that, 2 of the capacitors that were located over here and here were incorrect. Just wrong. And all 4 of these capacitors here should be the same. And they were 220 microfarads by 80 volts. Now I didn't have 80 volt ones, and I always upsized, so these are all now 100 volts. But they had in here 100 microfarads and 250 volt capacitors. And so they had these 2 correct, but these 2 were wrong. And all I can assume is they ran out of the correct capacitors and they used what they had, and for whatever reason it still worked, and so that's what they used. And so make sure that when you're going behind somebody that you're double checking their work as well. Don't assume it's correct. Luckily in this unit, this looks like the only thing that's been touched, which is really good because they used cheap components and they were making bad substitutions. So hopefully that's all they touched in here, and that'll just decrease my work. The other thing I noticed that when they did unsoldered this capacitor, and I think one more down here, they damaged the trace. And so not the end of the world. The damage wasn't very bad, but I did have to repair those traces as well. And so really all I did was solder the component in and use the leg of the capacitor to bend over and go to the next component in the circuit, and then solder it down there as well, just so it had a really good anchor. So usually when I see that, that means that they held the heat too long to the pad, and that's how they damaged it. I would say 99% of the time that's how the pads or the traces get damaged, is applying the heat too long. And that could be for a couple reasons. They might have used the wrong solder, and so they were having a hard time getting it to flow, or they were having a hard time with their wicking material to get the solder out as they were taking the components out. You know, I use my Hatco 301 gun, and that thing really does a good job. But even I sometimes, especially on the older stuff, you know, like the early circuit boards or whatnot, will damage traces, and it happens. But those are the 2 things that I really noticed when I worked on this board. I guess 3 things, right? 1, they used cheap components. 2, they used the wrong capacitors. And then 3, they damaged a few traces. But I was able to get all that taken care of. I've gone ahead and powered this up. I do get relay click, and I played some music through it, so everything is working as it should right now. So the next thing I think I'm going to work on is this lighting, because this is driving me absolutely nuts because it's just hanging in the way. And so I want to go ahead and get this fixed and get it out of the way because it's driving me crazy. So I'm going to go ahead and get some of my replacement sockets. So if you're getting one of these Pioneer 80 series or the 3 series, you know, like the 3600, the 3700, 38, 3900, and your sockets are damaged, you can go to my website, atoaudio.com, and I actually sell these sockets replacement, brand new sockets that I designed myself that you can put your LED bulbs right into, and they look just like the originals. And I'll show them here in a second because that's the next thing we're going to tackle. And so to do that, let me zoom you guys out. To do that, what I'm going to have to do is these metal pins here, I'm going to have to take these wires off and basically pull these pins out and install them into the new ones, and then rewrap the wires and then re-put them on this board. And so not really that big a deal now that I know how to do it. And I showed a video before of how to do this, but I think this will be a good reminder of how to do this process if you decide to buy my replacement sockets and do yours as well. And so the cool thing about that is that if you buy these and you install them, no one would ever know it's not original. They'll open this thing up and it'll look just like original. The one thing I will say is that if you buy my sockets, make sure you use LEDs. So the plastic will melt if we use incandescent lights, or they'll get soft over time. And so you don't want, this is why these are broken, is because they used incandescent bulbs, and that heat just makes everything brittle over time. So make sure you're using LEDs if you decide to purchase the sockets from me. So I'm going to go ahead and I think I'm just going to cut this out, this wire out, and then that way it'll give me full access to go ahead and make my own, hell, I don't know what to call this, make my own lighting something. I'm sorry guys, my mind just went blank. But then that way I don't have to worry about getting in the way. And I may just move the receiver out, and then we can focus on doing this, and I think that'll be a good refresher. So let me go ahead and do that, and then we come back on the bench, we'll get started on replacing these sockets. Okay, so I've went ahead and removed this harness. There's the word I was looking for, harness. Lighting harness from the receiver so we can work on it. And so if you order the replacement sockets from me, this is what you'll get right here. It'll be just the plastic piece. So we need to remove these metal pieces out there and insert into here so we can get this to function like it did. So I'm going to do the first one on camera, and then I'll break off and do the last two off camera. Now there is a problem. So when we upgrade to LEDs, the LEDs are a little bit longer, and this middle one, for the N2, it's not really a problem, but for this middle one, the LED is too long and it hits the back of the indicator lights harness, or bracket rather. So I'm not sure what I'm going to do there. You know, what I could do is make this deeper a little bit and print out a new one, and then that way it would see correctly. I could, you know, so I don't know if I'm going to do that, or if I'm going to figure out a way to shorten the LED itself, or I'm not entirely sure. Either way, we've got to get these pieces of metal out. And so what I'm going to do is I use my wire wrap tool, and I'm going to unwrap, and we'll just start on the end here. Unwrap this wire from it, and then I'll use hopefully a small screwdriver or something to take it out. So if you haven't got if you're doing a lot of this work and you haven't got a wire wrap tool yet, man, I highly suggest getting one. It just makes things a lot easier when it comes to getting the wire off of these things. So we're just gonna unwrap the wire. And that slides right off. It looks like we twisted the posts a little bit, so I want to make sure we straighten those out. Must be pretty soft metal to do that. All right, so from there, what we have to do is get a small, tiny screwdriver and depress. It's going to be hard to see, so I really want you guys to go refer back to the other video, because I do a close-up and probably make this better. But anyways, these holes here on the end, I think there's a little indentation that we're going to push in, and then we should be able to slide those pins back up out of it after we've depressed it. And sometimes it's easier to come from the top and just kind of pull it in. These things are falling apart in my hand as I'm doing this. And so that's all there is to it. So we got this first one out now. And so all we're going to do is just take it and slide it right back in to my other socket. So I need to straighten this post out again. And then, like I said, it's a direct replacement. So that goes in. Use a screwdriver to seat it. And now it's in there. So we'll do the same thing on this other one. It's unbelievable how brittle these things are after all this time. And it slides out just like that. Straighten up the post. And we're ready to insert it back in. Here's the little pin, so I'm going to push that out so it engages in the new one. And that's it. So now they're in there, and all we have to do now is wrap our wires around it. So I'm going to be using the same color wire. I've got this solid wire, so we're going to be using yellow and black. And all I'm going to do, guys, is wrap yellow here going to the circuit board, and then black here going to the circuit board, and then we'll just daisy chain these together, making sure that we're giving ourselves enough slack in the wire to do that. Once we've done that with all three of these, all we have to do is solder that last lead back onto the circuit board, and these things will be ready to go. So I'm going to go ahead and finish changing out the pins in these other two sockets, and I'll go ahead and wire up the harness, and when we come back, we'll just solder it back onto the board, and you guys can see me do that. Okay guys, so as you can see, we've gone ahead and made our wiring harness. We've replaced all the light sockets, and so this is going to work out really well. So we're going to go ahead and solder this back into the circuit board and install this in the receiver. So let me go ahead and get the receiver up here, and we'll go ahead and put this in. Okay, here we are back at the receiver, and so I'm going to go ahead and install this without the bulbs in it right now. And so as you can see, those light sockets are direct replacement. They go right in. We can kind of tuck our wires as we put this in. And that's how easy it is to change your lights out. So if you've got one of these 80 series or the model series after this that starts with a 3, the 3900, 3800, 3700, 3600, these light sockets actually work in those as well. And so that's how easy it is. Now we're able to keep this looking exactly like it did, manufacturer spec, and get some more use out of it. So all we have to do now is solder these wires back onto the board. So let me make sure I turned on my soldering iron. And we're going to be soldering over here on this, I think it's pin 6 or 9? 6? Pin 6 and pin 29. And so we'll just, actually on pin 29, I'm going to wrap the wire because it's a clean terminal. So I can wrap it using my wire wrap tool. And then the other one's got a wire soldered onto it already, so I can't wrap that one. But I'm just use my wire wrap tool. And there we are, that one's done. And then once my soldering iron gets up to heat, we'll go ahead and I'm going to try to get at least one wrap on the top terminal here, and then we'll throw some solder on it and we'll be done as well. So we got a couple wraps on it. Now we're just going to throw a little solder on top of it to keep it in place, since we couldn't wrap the whole thing. And that's it. We're done. So I should be able to put bulbs in these now and test it. So I'll go ahead and do that. This middle one, I'm going to probably wind up taking off the light diffuser and putting the bulb in, because it's a pretty tight fit, but because it has the indicator lights right behind it. Oh, the bulb just fell out. And go ahead and turn it on. And we got power and it's working. So this is a successful thing. I'm going to go ahead and do that so you guys can see me on camera. So let me go ahead and adjust fire and we'll do that real quick. All right, we're back. So I wanted to replace the bulb. So I went and got some new bulbs. And just make sure that the length on these isn't going to be an issue. And this one we know is an issue. These other two, they're good in the back. So this one, we're going to take the light diffuser off and then put the bulb in, and then put the light diffuser back on. So I'm going to, sometimes when there's not enough room, guys, you can kind of clip the back of these LED bulbs off, and that'll give you some wiggle room. So all you have to do is just kind of untwist the wire and trim off maybe about half the length, and that'll give you a little more wiggle room, a little more space. You'll cut a little bit off the wires. I suggest where the bin was originally. Obviously making sure you're not getting the wire in the receiver. And then you'll wrap that wire back around the case. And then you've basically essentially just trimmed a little bit off that LED. So because I know this is going to be a tight fit, I'm going to take the light diffuser off first. And I can do that by these two screws on the side. We'll wind up doing this again when we change these indicator lights below, but that allows me to have a little more wiggle room when putting this bulb in. So now that I've done that, I can just slide the bulb in, put it back in the socket, and then we can use that. These are kind of elastic, and this one's actually still got its elasticity a lot. So we're going to be able to just put it right back on. And just like that, we're ready to rock and go, and all our LEDs are working. So looks good. The customer had these blue LEDs in it originally, so I'm assuming they want blue back in there, but I'm probably going to reach back out to him, just confirm that to ensure that that's what he wants. But now that we've done that, we're ready to move on to the next part of this restore. And I think for us guys, that's going to be the amp boards. And so let me go ahead and get adjusted and figure out how we're going to take these out. We'll come back here on the bench in a second. All right, to get these amp boards out, I don't think it's going to be as bad as what I initially thought. But we're going to find out together, because I've never taken these ones out before. But before we begin, there are two feedback diodes on these boards. One for each board, the left and right channel. So we got one here and one over here. And so these over time become brittle and the wires will break right out of them. So we want to pay close attention to these and be very, very careful. So we need to loosen both of these screws. And then on the top of these boards, on this side here and here, and then here and here on the top of the boards, there's two screws. I think once we loosen those screws up, that's going to allow us to flip the board over after we pull these wires. And these are quick disconnects here, so that'll allow us to lay the board sideways, and I think that'll give us enough room to do the soldering. I'm going to take a picture and put it up on the screen, kind of at the bottom of the board with a little bracket. Basically the board should just slide out. So let's go ahead and loosen these screws up and see if that gives us access to it. So like I said, let's be careful with these diodes. You don't have to take the screw all the way out, just enough to loosen it up. And we're just going to gently pull those out of the way. Let's go ahead and wiggle these back and forth and get them to come off. I didn't say this, but very important to take a picture before you begin this process so you know where everything goes. This is pretty self-explanatory, but get overconfident and screw something up, so I don't want to do that. So I didn't realize this, but we still have two wires on each side that's going to be connected, so that may be an issue later on. So let's just do this side first and see if that's going to give us enough to wiggle these boards out. Okay, so we'll just do this side. From there, this allows me to kind of pull up on the board, hopefully. Yeah, I don't know. Ain't much wiggle room there. So we may have to adjust fire on that. I really don't want to pull this whole heatsink out, but we may have to. If we do, there's screws here and here on the bottom, but I really don't want to do that. I'm trying to think if there's another way, better way to do this. Maybe I can feed. Sorry guys, this is probably boring to see me do this, trying to figure out how I'm going to take these out. I was trying to do it without removing this whole apparatus here, but I may have to. I was thinking if I could get enough room, I could unsolder these pins here and lay the board this way and then just solder on the back. But I don't know if that's going to give me enough room. So let me think about this and we'll regroup here in a second. So bad news, I think I'm going to have to go ahead and remove that. And so to do that, there are 4 screws on each one of these corners, straight down on these brackets. And now, if I remember, I'll try to take a picture and put it up on the screen for you guys. And I really hope that once I do that, this will come on out. So let's try it and see if we get lucky. Alright, so that was the way to go. So I'm just going to set that heatsink with the output transistors off to the side. So now that we've got access to these boards, not as much access as I would like, but we've got enough room where we can unsolder these components and swap out some of these components. So that's the way to do it, guys, is we got the 2 screws up top of the circuit boards we have to remove. We want to loosen up the screws holding these feedback diodes in. And then the 4 screws on the heatsink itself, and then that whole unit will lift up out of the way and give you access to the amp boards. I think that's all I'm going to do to get to this, to solder, desolder, and solder on the new components. So let me go ahead and refer to the service manual and ensure that I'm going to be putting in the right parts, and we'll go ahead and start on one of these amp boards. Alright guys, so I decided to go ahead and unsolder these pins. And so that's pretty easy to do, and it allows me to lay these boards out the back of the receiver and give me a lot more access and room for my hands. So that's what I'm going to do. So let me see if you guys get a good view of this amp board here. Let's kind of zoom in a little bit. And so when we look on this amp board, and you have to forgive, I'm sure some things are blocked. We've got 1, 2, 3, 4, 5, 6, 7 transistors, and only 2 electrolytic capacitors, and the rest are film capacitors. So this would be a pretty straightforward here to replace. So I am just going to plug and chug on this one. As always, make sure that you're making equivalent substitutions for your transistors. I'm not sure which transistors these are going to take so far, but it's either going to be the 940s or 2073s. If not those, it may be the same ones that I used in the power supply, and I think those were the MJE 150, 30, and 31. And so I'll have to just reference the schematic to make sure I'm making a good substitution, the service manual. And so from there, I'll do this circuit board and then the other. So this is the left and right channels, and then we can put it all back together. So I'm going to go ahead and do that off camera. Remember, as we've talked about in previous videos, for capacitors, you know, there's not a lot of electrolytic capacitors on this amp board, but we want to make sure that we keep the capacitance the same. You can go up on voltage if you want to. These are pretty small electrolytic capacitors, so there must not be much voltage associated with them. And then the other big thing, guys, is making sure that you're making good subs for your transistors and you're paying close attention to the pinout. And so very, very important that we do that, and we're paying close attention to that. So if you guys have any questions about what my substitutions are or how I did this, leave them down in the comments below, but I'm going to go ahead and do that off camera. And what I'll do is I'll do the left and right channel, and then we'll come back once we've got it assembled. All right, so you guys will have to forgive if y'all hear the rain and thunder outside. Getting a storm right now, so if you guys hear that, I apologize. But we've got the amp boards complete, and so what we did with both amp boards is we obviously we took out that heat sink. We unsoldered these pins here and here on both boards to give us access, and with that we were able to get the boards on the back side and change out all the electrolytic capacitors and the transistors. Now for the electrolytic capacitors, you notice that they were that orange color, and I'll see if I got one here kind of in that bag there. And so I did decide to change those out with films because I had a whole bunch of those film capacitors, and so I just went ahead and swapped them out for films. The transistors, everything went smooth on this. Again, obviously watch your pinout. Even when I was doing one of these, I was very close to putting one of the transistors in backwards, and so just make sure you're paying attention with that. There were a couple transistors on here that I didn't know the substitutions of right away. A KSA 912, and I think I wound up substituting that with the KSA 1013. I'm sorry, 2SA 912 to a KSA 1013, a 2SC 1775, and I want to say I changed that out to a KSC 1845. Don't quote me there, I don't have it written down. And then there was a 2SC 1885, and I substituted that with a KSC 2383. And so, you know, just did a little research, you know, and made sure that those would be good substitutions. And ultimately what I did was put it all back together, and I just listened to it for about 20 minutes, and it sounds great. And, you know, not that this is necessary, but when I listen to it, I go ahead and I take out my infrared temp gun, and I just kind of shoot temps too, just to make sure nothing's abnormally hot. And everything sounded really good. So what we need to do at some point is obviously set the DC balance and idle current on this, but I'm probably going to wait till I finish the rest of the restore. From here, I think what we're going to do is flip this over and go to the protection board. It's got a little protection board with the relay on it, and so I'll flip that over here in a second and show you guys. But pretty much everything went as planned on the amp boards. No complications. You know, getting this heat sink in and out, you know, wasn't too bad, you know, but I would definitely recommend, and honestly I don't see how you could get access to those boards without removing this whole thing. I know we talked about it before, but just make sure you pay attention to these feedback diodes here and here, that you're very careful with those and you don't break those. And then, like I said, unsoldering these pins really made it a lot easier. And so that went pretty smooth. So we'll go ahead and flip this over and we'll get to the protection board and I'll show you guys what that looks like and where we're going to go from there. All right, so here guys we have the protection board, and as you can see there's not much to this protection board, pretty small. We've got 1, 2, 3, 4 electrolytic capacitors and looks like just 2 transistors and this IC. Obviously you won't be replacing the IC. Obviously this is working, so we'll go ahead and substitute these out. I think it's kind of neat on this, you know, they've got it far enough away from the power supply now. None of these caps, the outside plastic layer has shrunk, and so a lot of times when you're looking at capacitors, especially on the power supply section, the heat will basically make this plastic that goes around the capacitor shrink, and you'll see a lot more of the head of the capacitor exposed. And so that's a good telltale sign that that capacitor's been getting hot or has been in a high heat environment, and you don't see that on this. So this is at the bottom of the board. The protection, not the protection, the power supply board's on top of it, which was different than what they did in some of their previous units in the 50 and X3X series. And I think that was an improvement because now it allows that heat not to get trapped in the bottom of the unit, but to be able to escape from the top. When I was shooting the temperatures on the power supply board as I was playing it for the last 20 minutes, I didn't really see too crazy of temperatures. And so, I was playing it pretty hard too. I've got my Pioneer APM 100 speakers in here, so I can turn it up pretty good. And I think the most I got on one of the transistors around 120 on the heatsink, so that's pretty good. So we'll go ahead and swap these out. I don't know what transistors these are yet until I pull them out. So, but kind of like we do with everything, the capacitors we're just going to pull out and replace. Again, okay to change the voltage. You can upsize the voltage a little bit, but we're going to keep the capacitance the same. And then the transistors, I'm just going to make sure I pay attention to my substitutions. You know, these look like they may be KSA 992s. I don't know, I haven't looked at them yet to see what they could be. So as I get them pulled out, I'll make that decision on what we're going to do. This relay has something taped around it, you know, and that looks like it came from the manufacturer and has something here, and I don't really know what that's about, but I'm not going to mess with it. Everything's working, so I don't know if that looks like it came from the manufacturer. A lot of times you'll see this tape sometimes around meters to hold it in. The problem when you see it around meters, and I actually had a really good example of this on a Sansui 6060 the other day. This tape over time, if it's heated up, you know, it'll melt some of the adhesive and get on the meters themselves, and it's a pain in the butt to clean out. And I think a lot of people will throw those meters away, but I was able to save those meters, and I really wish I had done a video on it because it's something I think most people would not have thought to do, to take the meters apart and actually clean them. And I was able to basically completely restore those meters and get them looking brand new again without having to, you know, find a meter from another unit. So that's the only thing about this, but obviously this relay is not getting hot, so not an issue there. There's no cosmetic thing we're going to see here, so no problems there. So we'll go ahead and off camera, I'll go ahead and change out these capacitors and these transistors. And if there's anything unusual, I'll let you guys know once we're done. To remove this board, there's 4 plastic grommets in the corners. So here, 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 and here, and each of the corners. And so we'll just depress these tabs, and then this should slide out. Looks like the only wires are attached on this side, so we should be able to lay it this way and give us access to the back of the board. And so this should be pretty straightforward plug and chug. So I'm going to go ahead and do that, and we'll come back here in a few minutes. All right, so I'm done with the protection board, and so everything went very smooth with that. You know, initially I told you guys there was only 4 electrolytic capacitors, but there was actually one on the 2 pins over here, and so I didn't see that initially, but I went ahead and replaced that as well. Important thing to know about this one, guys, is one, watch your polarity when if you're replacing this, if you don't have a schematic. The positive side is going to go on pin 3, and the cathode negative side is going to go on pin 2. The other thing is this is a 1 microfarad 80 volt capacitor, and so a lot of people don't have those high voltages. And I didn't have the 80 volt, but I had a 100 volt, so I swapped that out. One other interesting thing to note on this board, if you've watched my previous videos when I've done the X3X series, the 50 series Pioneers, a lot of times we'll install a flyback diode on one of the pins of the board to protect it from sudden de-energization. With this board, they've actually got that already installed, and so Pioneer obviously learned and made some improvements in their designs, and it's actually this diode right here that acts as the flyback diode for this board, and so we don't have to add one to this board like you've seen me doing in previous videos. And so I thought that was kind of neat. And so it's cool when you work on these and you work on the different series, you know, for the X3X series first and the 50 series and now the 80 series, you can see that they're making improvements to the circuit designs as they go along the way. So that went very smoothly. The biggest pain in the butt actually was getting it off these plastic grommets. I hate these things, and so I really wish they would just put binding posts here with screws, because that would be so much easier, and those would be made out of metal and wouldn't decay or break over time. Getting this particular one on this corner out was just a pain in the butt. So, but it did come out, and so we made our substitutions. Transistor wise, one of them was a KSA 992 and the other one was a 2383, so nothing too fancy there. So everything went good. I'm going to probably move on to cleaning the controls. I don't think I'm going to recap any of the tone boards. I'm going to take a look at them real quick. Everything's working really good in this unit, so I think we're coming to getting close to the end. So I'm going to go ahead and test this, make sure it's working, and then we'll come back here in a few minutes and I'll let you guys know what the next step we're going to do to this unit is. All right, so I've decided the next thing I'm going to do is go ahead and clean all the controls. So electronically, there's not much left to do to this. I do still need to set the DC and idle current. I do need to change out these indicator lights here. The other bulbs have been changed out. So kind of getting towards the end. So I'm not going to go and show you guys my exact cleaning process, because I've done that on several videos before. But basically, I have two products I use. I have a DeoxIT D5, and that'll go on all the metal to metal. So the switches, basically these push switches and these switches here. And then for the potentiometers, I'm going to be using the DeoxIT fader F5. And so these switches, if you look right up at the top here, and I'll see, I don't know if I'll be able to really get a great shot of it. I guess it ain't too bad. If you look right up in here, there's a little gap. And what I'm going to do is I'm going to take my little straw and I'm going to put in that gap and spray a generous amount of the D5 in there. And then from there, I'll just work the switch back and forth a bunch of times, probably 20, 30 times easy, maybe more. It doesn't have, there's no exact number, you know, sometimes you do it more, sometimes you do it less, depending on if that switch is dirty or not. I'm not getting any static or any popping from any of the switches now, so that won't be a problem. Now to do these controls down here, let me turn you. See if we can get a little bit better. You know, right here at the very top, when you put the switch down, you can put your straw in there and spray in there, and you can do the same thing on the bottom. Again, put a generous amount, don't be stingy, and then you just work these switches back and forth. From there, I'll flip the receiver over. I'm going to have to take some of these nuts off on the front of the unit. And so these potentiometers, we've got a nut here, 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 and then over on here. And all those nuts will have to come off. And I think once those nuts come off, I don't think there's any screws, but I think there might be a couple screws we have to take off. But that'll allow me to take out those tone boards, and then I'll flush the potentiometers. And basically all I'm going to do is kind of the same concept. If there's an opening in the potentiometer, I'm going to be spraying that fader lube, the F5 in there, and then moving the potentiometers back and forth just to get any carbon off of them. So that's how I'm going to clean the controls. I'll save you guys the boredom of watching me do that. So I'll go ahead and do that off camera. And when we come back, we'll probably move on to maybe doing some of the sliding, and I'll maybe I'll touch on what I'm going to do there. I think most of the lighting works. It looks like these two lights have been replaced with LEDs before. They were kind of sloppy on one of them because some of the wires exposed, so I'm going to clean that up, and then I'll check these and make sure that we have LEDs in them and probably change them out as well. I think we're missing LEDs on a couple of these because this phono is not really working that well at all as well. One thing I forgot to mention is that I'm going to calibrate these power meters as well. And so I want to make sure that they're reading the same, and so I'll refer to the service manual and we'll do that together as well from there. And so I think we'll be in pretty good shape from there. So let me go ahead and start cleaning these controls, and we'll be back in a little bit. All right, guys, so I wanted to point this out. As I was cleaning the controls, I noticed a couple transistors here, and I just happened to look at a couple of them. And these two with the blue dots on them are 2SA726s, and these are known problem transistors that get noisy over time. So originally I wasn't going to do anything to this board, but I am going to go ahead and replace these two transistors. We're not having any problems right now, but I don't want this to become an issue later down the road for the owner. Especially, you know, two transistors won't take me long to do, to swap them out. And these are actually FETs, so I'll leave those alone. And then the capacitors I'm going to leave alone as well. And so I usually don't just do a shotgun capacitor change on these boards because of my experience, it just doesn't need it. So I do just the critical areas, which is the power supply, protection circuit, and then the amps, because that's really where the heart of the unit is. And I find that those go under wear a lot, but not necessarily the tone boards. So I am going to go ahead and replace those transistors, and those are going to be used with KSA 992s. Now, because they have the blue dot on there, we've talked about this before, that means that these need to be gain matched. And so I'll find a pair that are closely gain matched within five points hopefully of each other, and then I'll use those and substitute those. And so I've gone ahead and flushed all this stuff out already. And so this is my volume and my balance. And so while I'm here, I'm going to go ahead and change out these transistors. So I just wanted to point that out. If you are restoring this Pioneer SX-980, probably a good idea to go ahead and do while you're swapping out stuff is to go ahead and pull these transistors out. So I'll go ahead and keep on doing that, and I'll finish up cleaning the controls, and we'll come back in a little bit. All right, so got all the controls cleaned now. Just powered it up and tested it out. Everything sounds really good. So next, I think I'm going to move on to the indicator lights. And so we already changed the sockets. You saw me do that earlier. So we're going to have to remove this diffuser, kind of put it out of the way, and then that'll give us better access to the indicator lights beneath it. And so to do that, there's two screws on either side. So I'll go ahead and remove those. That'll allow me to kind of set this back. And then I have a lot more room here to move my hands around. And so these here are what holds the bulbs in, and these ones are actually still very flexible, which to me tells me that this unit didn't get used a lot. Because usually what I see happening a lot of times is that as the incandescent bulbs are in here, they just cook these, and basically they become really hard. Now this one here in the middle is the closest to the bulb in the middle as well, and so this one's got a little more wear than most of the other ones because there's heat coming from the back end of this as well. And that one's actually for the AM, so I doubt that the AM was used as often, but it's probably the heat from the other bulb over here and the back side that caused that. But everything else is still pretty flexible. This one's a little stiff, and that was the FM, so that's probably why. These other ones, the phono and the aux, and even this AM is still really flexible. So we're going to go ahead and remove these wires, remove these bulbs, and we're going to replace everything with LEDs. Now some people would put a white LED in these, and I may do that on a couple of them, But because each one has a particular color, sometimes what I do is try to match the color. So like the stereo is like yellow. The FM is kind of got a blue tinge to it, AM reddish, aux green, and phono kind of a bluish thing too. So I may put actually colored LEDs in here to attenuate the actual color of the indicator itself. Sometimes when you put the whites in here, it's so bright that it kind of bleeds through and it doesn't really show you the color of the indicator light. And so I don't know, I may do a test on one of them and see how I like it and go from there. So to do this, we have to be very careful, and I'm going to start here on the, oh, well, that just came right out. And this is the phono bulb. So we could do this a couple ways. We can cut into this wire and then splice our wires into it, which is what most people will do. We could follow these wires back and then tie in there, but I'm probably not going to do that because those wires are wire wrapped and I don't feel like unwrapping them and redoing that, so we'll probably splice into the wires. So I'm not going to show you guys that process. You've seen it on other videos. The big thing is when we swap to LEDs, obviously we've got to get the polarity right as far as what is the positive and negative side, because the positive side we're obviously going to put our resistor so we don't burn our LED out. So just pay attention to that, and the way you can do that is just cut one of these wires or follow them back to the circuit board and then test the positive to ground and see where your voltage is, and then you can figure out, or you can just do trial and error. If it don't want to work one way, just flip it around and do it the other way. So I'm going to go ahead and do that and change out these indicator lights. There's 5 of them here, so this shouldn't take too long, but it'll make a big difference as far as heat in here and also preserving these still flexible light holders here. And so this may be something I make one day in my 3D printer, so then that way, you know, if yours is broken, that you could literally just purchase that, and maybe I'll come with the LEDs as well, so that way they just perfectly pop in there. But who knows, I got so much stuff to do, you never know when you're going to have time to engineer something like this. But I'm going to go ahead and do that off camera. When we come back, I'll show you guys what it looks like in the front of the receiver. All right, so here we are. We've got the lighting done, and as you can tell, it's looking pretty good. So we've got our stereo back to yellow, blue FM, AM, auxiliary, and phono. So we've got some really nice colors there. Everything's working good. It's so funny to me how much of a difference it makes when just the lights work. You know, they're just the little cosmetic details to make a stereo look good. So it's a little frustrating when I changed a couple of these. Somebody had been here changing some of the lights before, and they really just did a half-butt job. I mean, just really sloppy work. And so sometimes I hate working on stuff after somebody else has been in there, just for that very reason. But not a big deal. Got it fixed. Everything looks good now. Everything's, you know, when I do my splices or whatnot, I solder everything together and then I wrap it with heat shrink. And some people just don't take the time to do those things. And, you know, will it cause a problem later on? You know, your guess is as good as mine. Maybe it can, you know, if the wire comes loose, creates a short. But it's just, you know, why take the time to do it if you're not going to do it right? So, but anyways, the lighting's all done on this. So I think there's only a couple things left to do right now. And so one is obviously we need to still do the idle current and DC balance. We still need to calibrate the meters over here. And then this customer wants me to change the speaker ports in the back, I think, to banana plugs. And so this particular unit, I'm gonna turn it off, has a circuit board that the speaker connectors connect to. So I don't know if I'm going to be able to do that or not. So I'll take a look at that here in a little bit after we, I'm probably going to go ahead and do the idle current and DC offset and then move on to the power meters. And then from there I'll go from that, because after that, you know, pretty much it's pretty much done then. I will be building a custom case for this stereo as well. And so we'll do a separate video on that potentially if I'm not feeling lazy. But so far everything's going good, so time to move on to the next step. All right, so here we are in the amplifier section, and we're going to go ahead and adjust the DC offset. So I'm going to kind of walk through what we're going to do. And so we have two variable resistors, one here and here. And so we're going to be using variable resistor number 2, which I believe is this blue one. And so when we start turning, we'll find out, because our multimeter won't change. And so we're going to concern ourselves with pin 10. Now it's kind of a little bit deceiving in the service manual. It almost looks like pin 10 is down here, but it's actually way down here. And so we're going to connect our positive to pin 10 and then our ground to the stereo case. And from there we're going to turn our variable resistor until we get to as close as we can to 0 volts. So I'm going to go ahead and hook that up, and we'll get started. All right, so here we are. I've got my positive terminal hooked up to pin 10. Now remember, everything in here is energized right now, so I'm using a plastic screwdriver, and I've got my black probe connected to the frame, so grounded out. And so right now we're getting negative 0.28 volts, and so we want to be as close to 0 as possible. So if I was to turn this to millivolts right now, I'd get a low reading because it's reading off the chart. So we got to get it closer before we can switch over there. So let's go ahead and start turning. And so we're coming down. So right now we're reading, it's going back and forth right around 1 millivolt. And so really we could probably call it quits right now. The unit's been on for about 4 or 5 minutes, so I'm probably going to let it stabilize a little bit. And let's go here more. Oh, we went too far there. And so we're pretty close. I think we can still do better. These variable resistors are very touchy. And I think I'm going to call it right there. And so we're going back and forth just a few millivolts. And so I think that's where we're going to call it. So that's all there is to adjusting the DC offset on the amplifier. And so making sure we're on pin 10 down here and then grounded out. And then this actually using this blue variable resistor. Now this might change if someone's been in your receiver and swapped those out, but the manufacturer's one is blue, and so this white one's going to be used to do the idle current. And so I'm going to go ahead and look in the service manual while we have this set up for you guys to see this side of the amp board, because you really can't get a good view on the other side. We'll go ahead and do the idle current as well, and actually I see it's still going, so I'm going to kind of adjust it a little bit more. Probably as this warms up, I may go back to pin 10 and do this as we're doing the idle current as well. I should have left it alone, shouldn't I, guys? All right, I'm going to leave that for now. So I'm going to look in the service manual real quick, and we'll adjust our probes. So the service manual says to do the idle current on this side. We're going to put our terminal or probes on pins 13 and 23. And so 13 and 23 are going to be this pin here and then this pin over here. So the no wires are attached to those right now. Now when you do that, you'll want to make sure you check the polarity. If you get a negative reading, just know that you just got your probes backwards. It doesn't matter. I think that was a rookie mistake I made back in the day, thinking it did matter, but it doesn't. So right now we're reading at 21, almost 22 volts. And so let's see what the service manual wants us to be at. I lost my page. So the service manual wants us to be at 30 millivolts. So I like to be just under 30 millivolts, so we're going to go just up to like 28. Now it's a good thing to let this power on for a while before you do this. So we've been on, probably this procedur's probably been going on now for about 10 minutes, so we're in pretty good shape. So we're going to have our positive on pin 13 and our negative on pin 23, and we're going to be adjusting variable resistor number 1 here. And so let's see if we can't get a little bit closer to 30. Yep. I think we're going the opposite direction. Yep. So my goal was to get it to right around 28. So we're going back down. So let's see here. All right. So we've got a little bit of fluctuation, but you guys get the idea. We're just going to adjust this. And like I said, the service manual says 30. I'm going to be right around 28 is where my goal is. So now on this side of the amp board, which is the right side, we've adjusted the idle current and the DC offset. Now what I'm going to do, because it's been warming up more, I'm going to come back and I'm going to check my DC offset just to see if it's still right where we left it. And we've gone back a little bit more negative. And so as it's been warming up, so I'm going to go ahead and readjust this to get us a little bit closer. Now technically the service manual says you can be within plus or minus 30 millivolts on this. So I mean, that's okay, but I want to be closer to 0 than that. I think we can do a better job. So I'm going to leave it there. We'll come back and we'll double check our idle current. And it's right where we left it. So I'm going to call this side done. We're well within close, right on the money when it comes to the DC offset and idle current. So now I'm going to do the exact same thing to the opposite side, the left channel. And so I'm going to do that off camera since you guys saw me do this on camera. And when we come back, we'll adjust the power meters. So be back in a few. All right, so we're going to go ahead and start adjusting the power meters. And so I'll change the camera view to the meters themselves in just a second. But looking straight down on the front of the receiver to the left, you'll see these two variable resistors, and one's for the left and one's for the right channel or meter. And so that's what we're going to be adjusting. Now my multimeter leads are connected to speaker A output, both positive and negative, and then I have a signal generator producing a 1 kilohertz signal going into the aux. And so what the service manual wants us to do basically is turn up the volume and adjust that until we see 28 AC voltage out the terminals. And then we're going to adjust the power meters to where they read 0 dB. So I'm going to go ahead and change the camera view real quick and show you guys the meters, and then we'll go from there. So there's a lot going on, so I won't be able to show you guys the multimeter at the same time, but I'll at least show you guys the meters and kind of what it would look like if we do this correctly. So let me go ahead and adjust the camera, and we'll be right back. All right, so here's our power meters, and so 0 dB is right here, guys, and it correlates with the 80 watts. And so that's what we're going to be shooting for our test. So I'm going to go ahead and start turning up the volume here until we get to 28 AC volts. And it's kind of hard because the volume control has notches in it, so you can only go so far. And I think that's going to be as close as I can get it. So, and as you can tell, we're getting a little movement on the needles, but we're pretty spot on for the most part. I am getting some stray voltage somewhere. Not sure what that's about. All right. So now I'm going to go ahead and I'm going to try to stay out of camera view so you guys can see me adjust the needle. So I'm adjusting this one on the left side so you can kind of see it going back and forth. So I'm just going to get it to where I think it's right about 80. Now I'm going to do the other side, the right channel, and you can see I'm going back and forth on this one. Do the same thing, and both of them are right at 80 now. So turn the volume back down, and that's it. That's all there is to adjusting the power meters. So all you have to do is make sure you have a signal generator, and then you have your multimeter hooked up to your speaker terminals on the back so you can read the AC voltage. I think one of the first times I did this, one of my mistakes was I didn't change it into AC, and I was like, man, I'm not getting any voltage. What am I doing wrong? So just make sure if you're doing this that you're adjusting your meter to read AC voltage and not DC. And then it's pretty simple, pretty self-explanatory. So this unit is pretty much done. I think the only thing left to do is those banana plugs in the back for the speakers. And so I haven't done that before for this particular unit. So I'm going to take a look at that, and then I'll either show that or I won't. I'm going to take a look at it and see how involved it's going to be to do. And if I feel like it'll be good video, I'll go ahead and include that on this video as well. But other than that, electrically, this thing is ready to rock and roll. And I'm sure I'll hook it up to some speakers. We still have to build a case for it, so I don't know if I'll do a video on that or not, but stay tuned. Let me go ahead and see if we're going to change these speaker terminals in the back, and we'll be back in a few. All right, so here we are back at the stereo, and so I went ahead and took out the speaker ports because I wanted to see if I had enough clearance for these new ones that are going to go in there, and I do. So these come out by 4 screws, and then it just slides out the back. Before we go much further though, I would recommend taking a picture of this and notating the orientation that this went in, because it's going to be very important that we make sure that we connect this correctly into the new banana jacks that are going in the back of this receiver. And so I went ahead and wrote down, but this red wire is basically going to be the right positive of speaker A's, and then this blue wire is going to be the positive of speaker A left. Now the negatives are all basically joined together going back to ground here, so that's not important. We want to make sure that we have the positive side connected in the right orientation, and so I've gone ahead and notated that already, so especially before we start cutting wires. So like I said, the ground doesn't matter, but we definitely want to make sure that we put these back in order. So what I'm going to do is go ahead and start cutting. And so that way I can remove this, and you know, who knows, maybe this part will come in handy down the road for another repair. From there, I think the next thing I'm going to do, guys, is I'm going to put some flux on each of these and go ahead and put some solder. That way it just accepts the solder easier. And then I'll go ahead and put a jumper wire in between my two negative sides. And then that way all I have to do is I'll use one wire that joins to here and then another for the speaker Bs. And so let me, I'm going to move this off to the side a little bit so you guys can see that process. Heat up my soldering gun. And let's find us some wire. Doesn't really matter what wire I use, but I've got some black solid wire, solid core wire, so I'll use it. It doesn't have to be a big piece either, which is nice. And I'll just make 2 of those. Oop, that one went flying. While my solder gun is heating up, I'll go ahead and kind of take some off of each side. I'm going to take a little bit off because I'd like to do at least one wrap around the terminals, because a mechanical bond is always better than a solid bond. Let me move this camera so you guys can get a little bit better picture maybe. We can turn this a little bit. Angle down. So I think that's going to be a little bit better for you guys. So here's my 2 black wires. So I'm going to just take a little screwdriver and I'll coat. I'll start with these negative ones, I guess, first, and just kind of put some solder around the posts. This will just allow these posts to accept the solder easier, so that's why I'm putting flux on all of them. Don't be too stingy here. Flux is cheap and it'll save you some headache on wondering why the wire or the solder is not attaching to the terminals. So let's go ahead and lob it on there and get some on there. We can always wipe off any excess. Okay, so I'm just going to set that up like that. Make sure you guys can still see. Now my iron is nice and hot, so I'm going to go ahead and start putting some solder on these. And hopefully this will take the solder very well. Looks like it is. Kind of hard to see from my angle. It looks like we're getting a lot of good solder on there, so I'd say that one's pretty good. Let's go ahead and do the same thing for the next one. On that one, I think. And so the solder will usually follow the heat. So I'm just trying to get some around there. All right. Sometimes this can be a pain in the butt. Just be patient. you'll get the solder on there. It doesn't have to be perfect. You can melt it and make it look like anything you want it to look like. So there we have it. Now the next step is going to be basically connecting a connector in between the two grounding posts. So this doesn't have to be pretty or anything, so I'm just going to wrap it. And actually, you know, I think I'm going to give myself a little bit more wire to work with, so I can maybe get an extra wrap or two. I'll go ahead and do the same thing here on this one. I know that's hard for you guys to see, but I've just wrapped those. So basically, literally, I've connected those. And so that'll be important when we go ahead and attach one of our ground wires to it later. So now that I've done that, I'm going to go ahead and heat up the solder again. So that way it kind of takes that wire. Very nicely. Okay. So that one's done. Let's do the same thing here. Want a really good joint. I don't want this coming off. And now we have this soldered in between, and it's not going anywhere. So that's good. So we can put that one off to the side, and we'll just sit it there, and we'll do the exact same thing for this one. So I'll do that one off camera, and then we'll come back, and then we'll be ready to go ahead and solder the wires to them. So let me go ahead and do that off camera, and then when we're ready, we'll come back and go ahead and start installing it in the receiver. All right, I'm going to do my best to walk you guys through this. I know it's hard to see because everything's kind of small, but so we've got both of these ready to go to accept the wires, and so we're going to start on speaker A's first. And so speaker A will need a ground connected here. The top will be the red and the bottom will be blue. So we'll wrap these wires, heat up the solder, and then add more solder to them to make that connection. And then we'll have to kind of shimmy it in here because it's a pretty tight fit. But we'll start with this red wire since we've got plenty of slack on it. And I'm just going to wrap that wire. And then I'm going to go ahead and solder it. Let me see if am I still in camera view here. Now I'm going to add some more flux because the wire didn't have any solder on it yet, but I figured it'd be easier to wrap that way. So I'm just going to add some more flux. Remember, flux draws in the solder and just allows it to take it a lot easier, so don't be shy. We want to make sure we have a really good electrical connection here. We don't want these ever to come loose. So apply the heat and allow the solder to flow to where the heat source is, and that's all I'm doing. And so now I've got this on there really well. It's not going anywhere. That's not coming off. Now we'll do our next longest wire, which is this black wire. And guys, if you're doing this and your wires are too short, there's no rule that says you can't lengthen your wire. So just to add a piece of wire in there, I would recommend soldering it together and then putting heat shrink over it. My wires, I think, are long enough, so I'm going to go ahead and leave it alone. I say that, then I wonder how I'm going to. This is when you need 3 hands, guys. It's clear, it's obvious that I need 3 hands. But I have, never fear, I have a solution. Thought I had a solution. We'll just alligator clip it there. It's still not sturdy enough for my liking. I have one of these helping hand things, so maybe I'll use it. Bear with me, guys, as I get adjusted here. I think that'll allow me to hold it into place. So I'm going to adjust this camera view so you guys can get a better view of what I'm doing. So I just got my helping hand, so I'm going to solder this black wire on. I'm going to go ahead and add some flux to the wire as well. And since we've already got a generous portion of solder on there, I'll go ahead and tack it on like so, and then I can come back and add more solder, and hopefully it doesn't just fall right off, but we'll see. Like that. That's okay, we got it nice and hot, so we'll just stick it in there. There it is. Now we need to do our blue wire here on the bottom. Again, I think I've got enough wire, so I'm going to go ahead and wrap it around. Add some flux. Ooh, I definitely wasn't stingy on that one. We'll hit it with solder. Now, another thing you can do, guys, is put the solder on the reverse side of where your heat source is, and the heat will draw the solder around, just like that, and you'll get a good connection. And so I'm still going to add a little more solder because I like to cover it. I don't like to take any chances. There we go. Now we got plenty of solder. Our wire's not going anywhere. And just like that, we've got the first set done, and it's ready to go in. Now, like I said before, this one is the tough one because it's in between the case here. So you have to kind of shimmy it in and twist at the same time. And I'm going to tuck some of my wires out of the way because it gets caught. But once you get it in, there we go. It should just slide in, and there it is. So that's the first set done. Just check all my connections. Everything's still connected, so we're in good shape. Now, the thing I didn't like, the customer sent me this, but there's got holes here, but there's nothing to screw it into. So I'm going to have to come up with something to figure out how I'm going to secure this board in here. And I think I may just have to do a small nut and a screw, but other than that, this kit or wherever they got this from seems to be good. If it was me, I probably would have made a 3D printed a backer for this kit, and then that way it would screw in kind of similar to it screwing into the plastic of the other one, where you could use the original screws. But with this kit or whatever they gave me, that's just not possible. So it is what it is. It looks good. It's going to be super functional once this is done. So that's all there is to it, guys. Now I'm going to do the exact same thing for this one. And so the top wire on this one is going to be the orange, and then the bottom will be purple, and then this last ground will come here. So y'all saw me do one, so I'm not going to do this next one on camera, but we'll go ahead and do that off camera, and then when we come back, we'll have this all in, and hopefully I'll find some small screws or nuts that I can secure these, and then we'll do a test run. So we'll be back in a second. Okay, so this unit is pretty much done electrically wise. We still have to build a custom case for it and get that all squared away. But electrically, like I said, this thing's pretty solid. And so I just got done testing it, and so the speaker jacks that we put in, the banana clips, banana plugs, worked out really great. And so I'll put a picture of what that looked like up on the screen here. And so I think the customer's going to be really happy with that. And I think it's going to allow them to use a thicker gauge wire or do whatever they want to do. I don't think it was 100% necessary. You know, most of the wires that we use for these speakers is plenty fine, and but it is pretty convenient to be able to just plug it in and very quickly. So you know, I don't know if I will do that to my units. It's something I thought about doing before, but it actually went a lot smoother than I thought changing out those plugs. So that was always a win. So let's recap about what we've done with this receiver. And so we've completely rebuilt the power supply section and with new electrolytic capacitors and transistors. And all of the electrolytic capacitors, we upsized the voltage on there. And so I always think that's important because of the power supply is pretty much the heart of the unit. And so we want to make sure that we're giving the best components there. If you remember, when we started working on that power supply, somebody had been in there before and put a whole bunch of cheap capacitors in there, and also put in some of the wrong capacitors. And so we corrected all that and got that situated. From there, we moved on to the left and right amp boards, and so we changed out the couple of electrolytic capacitors there and the transistors on that board, on those boards as well. And then from there, we moved on to the protection circuit, where we changed out the electrolytic capacitors and transistors as well. We also started to do the cleaning on the potentiometers and switches. And while we were doing that, we looked in the tone board and we noticed that there were two transistors that were troublesome, noisy transistors that usually pop over time or create a problem. And I think those were the two SA726s. And so while we were there, we just went ahead and swapped those out and put in the KSA992s. So that'll just save the owner some heartache later down the road if he ever has to go back in. So we did a real good flush and clean of those switches and potentiometers. From there, we moved on to lighting and changed out all the lights and upgraded to LED bulbs. Also, before we put the new bulbs in, you know, we changed out all those sockets that the bulbs go into. Remember, the 80 series and also the series afterwards, the 3 series, they all use that same socket, and with those incandescent lights in them, they overheat and they get really brittle over time. Pretty much every single one of these units has broken clips in them. And so I've 3D printed that part, and it's available for sale on my website, atoaudio.com. And so I think that's a really, really good thing to do, especially if you want to try to keep it original, because these are direct replacements and they look identical to the original manufacturer ones. So once we did that, we went ahead and set the DC offset and also the idle current to manufacturer specs. From there, we moved on to the power meters, and we put in our signal and got the power meters calibrated, and those look good. And then lastly, we worked on those speaker posts. And so this thing has had a pretty good, generous restore on it. So from here, I'm going to move on to building a case. I don't think I'm going to make a video about that because this has been in my shop for some time and I just need to get it out and move on to the next project. So, but I'll go ahead and build a case for this SX-980. And so those are for sale on my website as well. And I have them in a couple of different options, you know, where you can put the logo, the tuning fork logo on it, or the Pioneer word and tuning fork logo on it as well. And so that's going to be next on the chopping block for this. But after that, this thing's ready to rock and roll and go back to its owner. And so I'm pretty excited about it. It turned out really good. I think this is the first one of this model I've worked on before. Maybe, I can't remember. But it was pretty straightforward. So if you got any questions about how to do anything that I've done on this model, please make sure to leave them in the comments section below. I do my best to always answer and respond to comments. If you guys have any requests or anything you have questions about, make sure to leave them down there. And if you haven't already, make sure you subscribe to the channel. And so we are growing, and support from viewers like you is what makes me able to keep doing this. And so, as always, thanks for watching, and we'll see you on the next video.